Hello guys, my name is Desmond and I welcome you to my YouTube channel. Ladies and gentlemen, for today's lesson we'll be looking at physical sciences, specifically a chapter called Vertical Projectile Motion in One Dimension. Ladies and gentlemen, it's very much important that you pay attention to everything that I'll be writing, and most importantly you listen very much carefully to what I'll be saying. Okay, so guys, without any waste of time, let's have a look at question number 3, and you're advised to start on a new page. Okay, so we're given a statement, and of course there's a diagram drawn below. I've also tried to redraw that diagram by hand. As you can see, ladies and gentlemen, remember what I like about physical sciences, it's not really about the level of accuracy in terms of the hand drawn diagram versus the given diagram. What matters the most is the dimensions, and most importantly, an understanding of the given statement. So guys, I'll just read through the given statement, quickly analyze the diagram drawn, and again go through each and every question. Okay, so if you've got something to write, you can just note down as I speak. And again, if you've got a calculator, when necessary, you can also punch, as I mentioned, some of the steps that I'll be taking. And again, ladies and gentlemen, if you haven't got any of those, you should surely have a glass of water. And then from there, by the end of this lesson, I'm going to make this lesson available on my YouTube channel under the playlist Free Live Online Lessons. So, ladies and gentlemen, a statement reads as follows: a hot air balloon is moving vertically upwards at a constant speed. A camera is accidentally dropped from the balloon at a height of 92.4 meters, as shown in the diagram below. The camera strikes the ground after 6 seconds. Ignore the effects of friction. So, ladies and gentlemen, I assume everyone is able to see on the diagram. Otherwise, if you're not able to see, please do make sure that you check out my Telegram channel. That's where I post these question papers, so you can freely access those question papers, ladies and gentlemen. So I'll just read it for the last time so you can just listen, and then from there we'll quickly analyze that diagram. So a hot air balloon is moving vertically upwards at a constant speed. Ladies and gentlemen, it's very much important that you note down this type of information. Okay, so out of that information or that sentence, what matters the most is for you to be able to understand that you've got a balloon which is moving vertically upwards at a constant speed. Very much important, ladies and gentlemen. A camera is accidentally dropped from the balloon at a height of 92.4 meters, as shown in the diagram below. Ladies and gentlemen, that camera is accidentally dropped while the balloon is moving vertically upwards at a constant speed. Very much important, ladies and gentlemen, that you understand the correlation between those two sentences. Okay, so the camera strikes the ground after 6 seconds. Okay, ignore the effects of friction. So guys, as you can see on the diagram, you've got somebody in there. Obviously, I think, this looks like a person who actually dropped the camera. So ladies and gentlemen, that part, it actually shows you in terms of error there that this balloon is actually moving vertically upwards, and we know from the statement they said it's moving at a constant velocity or speed. Okay, so a camera is accidentally dropped by this guy at a height of 92.4 meters. So that means after this balloon has moved vertically upwards and reached that height of 92.4 meters, our friend there, he actually he accidentally dropped a camera. So ladies and gentlemen, they said that camera strikes the ground after 6 seconds. Okay, so we can also see someone there who's actually 10 meters away from where the camera was vertically dropped downwards. Okay, so because of the experience and the questions that I've done in the previous years, I can already derive questions which will be based on this scenario. So ladies and gentlemen, let's now move to our very first question. Okay, so guys, remember this question is not that much difficult. Do not gauge the level of complexity of the question by simply looking at the diagram. Okay, so this diagram, you can visually interpret what's going on there, and obviously the manner in which questions are asked, it's what you should be careful of. Okay, there's nothing tricky on that diagram. It makes sense. Everything looks practical, and again, even the questions should be relevant and easy to answer or easy to solve. Okay, so guys, 3.1, the question says, at the instant the camera is dropped, it moves upwards. Ladies and gentlemen, this is this is a statement. Okay, it's not a suggestion, it's not a question, but instead it's a statement. Okay, so they say give a reason for this observation. Ladies and gentlemen, very, very much important that you fully understand this question. And I've done a lesson where I was teaching and also guiding you in terms of how the questions may be asked with regards to this chapter of vertical projectile motion in one direction. So I've given multiple scenarios in which questions may be asked, and this part was also included. So remember, for the purpose of today's lesson, it's not really to do a lot on the teaching, but instead showing you how to approach this type of questions based on the lessons that I've made. So in case if you want to know more about this chapter, please do make sure to check out that video on my YouTube channel. You'll find it under the very same playlist of free live online lessons. That's where you'll be able to see and watch this full lesson. So guys, the question says, at the instant the camera is dropped, it moves upwards. So that means, ladies and gentlemen, remember this balloon is moving upwards at a constant speed. Okay, very, very much important, ladies and gentlemen, a camera is accidentally dropped. Okay, so according to this statement of 3.1, it means the moment it's dropped, it doesn't straight away fall down. Okay, but instead it moves upwards. Okay, so what makes it to move upwards, ladies and gentlemen? That's what they want you to tell them when they say give a reason for this observation. Okay, ladies and gentlemen, an answer to this question is very, 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 very simple. You don't need to stress that much. And remember, most importantly, ladies and gentlemen, this question is allocated just 1 mark. Okay, so that means let's see, let me just do this and say we're actually on question number 3. So question 3.1, ladies and gentlemen, guys, I'm going to say this in the manner in which I'm going to say it, but it doesn't necessarily mean that at all times when you have this type of question, you should answer the question in the same way. Okay, very, very much important, ladies and gentlemen. Try to understand exactly how the question was asked. Very, very much important, ladies and gentlemen. Sorry, do not just provide the answer as I provide in my lessons. Listen very carefully to the question, read very carefully, read the question very carefully, and then from there, give the answer accordingly. Okay, so the initial velocity, ladies and gentlemen, or speed of the camera is the same as that of the balloon. Simple as that. So this is how you answer this question, ladies and gentlemen. I can just write it down if you like. So the V initial, which is the initial velocity or the initial speed of the camera, ladies and gentlemen, is the same as that of the balloon. So guys, this is how you provide an answer to this question, and they just give you 1 mark. Okay, ladies and gentlemen, for the purpose of this lesson, it's not really just to give you the answer to the questions, but instead to explain to you what actually happens there. So guys, this is a different scenario from a camera being dropped from a flat. Remember guys, a flat is not moving in any direction. Okay, so the difference is that you've got a moving balloon. In other scenarios, you may be having a building which is just standing. So in that case, ladies and gentlemen, when you drop something from a balcony, it doesn't move in any direction other than just falling downwards. Okay, so that's the difference. In this case, you've got an object which is already moving upwards. So when you release an object, it doesn't just go down, but instead it goes up for some time, and then from there it reaches its maximum height, and then it goes down, and then it passes that level where it was dropped either by intention or accidentally, and then it continues moving downwards until it hits the ground. Very, very much important, ladies and gentlemen, and I assume you fully understood that part. Okay, so guys, can we now move to the next question? Let's see, let me just wipe all of that information. So ladies and gentlemen, let's now move to question 3.2, and the question says, calculate the speed Vi at which the balloon is rising when the camera is dropped. And this question is allocated 4 marks. Ladies and gentlemen, they say calculate the speed, which is Vi, and you can see there you've got your Vi at which the balloon is rising when the camera is dropped. Okay, so ladies and gentlemen, with regards to this type of questions, the formulas are always the same. What changes is the scenario. So it all depends on your understanding of the given scenario. Okay, so ladies and gentlemen, there are multiple ways in which you can answer this type of questions, but I'm mostly interested in showing you the simplest way of going about these questions. Okay, and very, very much important, ladies and gentlemen, remember guys, you should be aware or take into consideration the direction in which whatever that is moving, it's moving in that particular direction. Okay, so for example, ladies and gentlemen, remember, as this camera is being dropped, okay, what it does, it goes up, and then from there it will obviously come down to that same level, and then it continues going down until it hits the ground. Okay, so now what the question wants you to calculate is Vi, which is the initial velocity. Okay, so remember, the initial velocity at which the camera is moving is the same initial velocity at which that balloon is moving, and most importantly, that balloon is moving at a constant speed. Okay, so this initial velocity is actually for the camera at the instant it is being dropped, and again is the same velocity or speed at which the hot balloon is moving upwards. Okay, very much important, ladies and gentlemen. So remember, as this camera is being dropped, okay, obviously it goes up, but remember its velocity starts to decrease as it goes up until it reaches its maximum height, where obviously its v final is equals to 0, and then from there it comes down. By the time it reaches that maximum height, remember obviously the balloon, it continues moving upwards. Okay, so it will move upward at that constant speed, but this one, as it moves up, its velocity decreases until it reaches its maximum height, where its velocity finally is 0, and then it comes down, it passes that same level where it was dropped, which was 92.4 meters above the ground. And then from there, they said it strikes the ground after 6 seconds. Ladies and gentlemen, it's very much important that you remember that when it comes to this chapter, we've got gravitational acceleration or force of gravity, okay, which is a 9.8. Depending on the direction that you choose, it could be positive, it could be negative. Okay, very much important, ladies and gentlemen, that you understand your approach. Okay, so for now, let me just wipe all of this information. I can promise you, as soon as we start with this question, that's when you'll be able to notice how simple this question is. Okay, so guys, can we try to check what information is available? I can see we've got change in y, which is 92.4 meters. Okay, and again we've got change in time. We're told that in 6 seconds, that's when it hits the ground. Okay, very much important, ladies and gentlemen. And again we've got our g, which is 9.8 meters per second, per square seconds. Okay, so ladies and gentlemen, it's very much important that at all times you assume your direction to be either positive or negative. Okay, so I fully understand that in some instances you might find that you get a little bit confused in terms of substitution, especially when you choose either up as positive and down as negative, or vice versa. So I think you'll be very much happy if I do this question in 2 ways. Okay, so the first way, let's just assume downwards to be positive or negative. Let's just assume it to be positive. Okay, so ladies and gentlemen, your next step is to try and find the most relevant formula. Okay, remember guys, the formula that I might choose, it doesn't necessarily mean that it is the formula that you should use at all times, or it's the right formula to use. It is the right formula to use, but not only the formula to use. You can either choose any of the formula to use based on the given information. Okay, so for now, as I'm looking at these formulas, I can see there I haven't got a change in y, which is one of the most important factors in the information given. V final there, what is it? I don't have time, so I wouldn't consider using that formula. Let's see, the third formula, delta y is there, v initial is there, which is what I'm looking for, time is there, acceleration is there. So this seems to be the relevant formula. So now let me check that other formula. There's change in y, there's v initial, but now because it involves final velocities, and again it doesn't have that g, then I won't consider using that formula. So now, ladies and gentlemen, let's consider using this formula, which says delta y, it's equals to, this formula says vi multiplied by delta time plus half g change in time squared. Okay, ladies and gentlemen, very, very much important in physical sciences that you write down this formula, okay? Because in most cases you're given marks for writing the correct formula, okay? So, ladies and gentlemen, let's now go back to our question. And okay, this question it's 3.2. Just wanted to write that this question is 3.2. Okay, so let's now substitute. Remember, guys, we are taking downwards as a positive. Okay, so ladies and gentlemen, remember, this is not just the distance. Okay, it's called a change in y. Okay, so others may refer to this as a displacement, I assume. Okay, so what I actually want you to understand is that this direction can either be positive or negative. Okay, very, very much important, ladies and gentlemen. If we assume downwards to be positive, so that means the distance covered from that level going upwards, it should be negative. Okay, very, very much important, ladies and gentlemen. But in this case, you might find that the questions that were being asked, it's not really to provide the distance or the displacement or the change in y covered by that object as it goes up. Okay, so in other ways, I'm saying we look at the change in y relative to the moving object. Okay, so ladies and gentlemen, let's now substitute. Remember, we are assuming downwards to be positive. Okay, so remember, this object, it initially goes upwards. Okay, goes upwards and then it goes downwards. Very, very much important, ladies and gentlemen. So now, as it goes downwards, it covers that distance, okay, from that level as it goes downwards. So that change in y, it's now positive. Okay, so that means we've got positive 92.4, okay, which is equals to, remember, the initial velocity is exactly what we're trying to calculate. So what is the time, guys? The time is 6 seconds. Okay, so time, ladies and gentlemen, is what we call a scalar quantity. Okay, what does it mean when we say time it's a scalar quantity? It's because it doesn't have direction, it only has magnitude. Okay, so let's now continue with the substitution. We've got 1/2. What about gravitational acceleration? So gravitational acceleration, it's a vector quantity, ladies and gentlemen, just like a delta y or change in y, just like initial velocity, which means it has both direction and magnitude or size. Okay, so that means when we substitute our g, we should take into consideration the sign, if it's positive or negative. Okay, so that means since our gravitational acceleration at all times, it's actually exerting objects downwards or towards the ground, it's positive. Okay, so that means we substitute positive 9.8 into the time, which is 6. Remember that squared, ladies and gentlemen, very, very much important, otherwise you will lose some marks as a result of getting incorrect values. Okay, so obviously what you do, ladies and gentlemen, is just to move all of this to the other side of the equal sign, and you divide by 6. Okay, so in short, that means our V initial will be equals to, I'm just going to punch all of this. So it's obviously positive 92.4. Then you subtract all of that, which is minus 0.5. Remember, it's half. Then positive 9.8, and then 6. Then you square, which is equals to negative 84. Then you divide by that 6. And the answer that you get, it's negative 14 meters per second. Okay, so ladies and gentlemen, why are we getting a negative number there? Reason to that is because a negative number tells us the direction in which our initial velocity is. Okay, so if we had a positive answer, that will mean the initial velocity in which the balloon is moving is downwards. Why downwards? Because we assumed downwards to be positive. Okay, so now that we got a negative number, what does it mean? It means, ladies and gentlemen, what it means is that our V initial is actually 14 meters per second in the upwards direction. Okay, so guys, this is how you solve for this question, assuming that downwards is positive. Okay, so I'm just quickly going to redo these questions, but assuming downwards to be negative in this case. Okay, not sure if I should erase all of that or just leave it, but otherwise let me just leave it and try to squeeze everything within this space. Okay, so ladies and gentlemen, I'm still going to be using the very same formula. I think let me not rewrite that formula again, but instead substitute. Okay, so ladies and gentlemen, what is our delta y? Remember, in this case we assume downwards to be negative. Okay, very, very much important, ladies and gentlemen. So that's what I meant by delta y in that case. Okay, so remember, from the given statement, they just indicated that the balloon is moving upwards. Okay, so obviously in the opposite direction as compared to this delta y. Okay, very, very much important, ladies and gentlemen, that you understand exactly what is going on over there. Okay, so guys, let's now substitute. So it becomes negative 92.4. Very, very much important, ladies and gentlemen. It becomes negative that value. Okay, so this is equals to our V initial. It's exactly what we're calculating. Remember, time is a scalar quantity, no need for direction, so it's just the value plus a half into, ladies and gentlemen, very, very much important that you understand that you assumed downwards to be negative. Okay, so that's why you've got negative 9.8. Okay, so with regards to your t, is the very same t, which is just 6. What matters the most is for you to remember that you've got a squared there. Okay, so guys, before we even find the value of that V initial, can we try to discuss how our answer should look like, considering the fact that we've already calculated that value over there, and again we've made an assumption there. My question to you is, our answer, will it be positive or will it be negative? Ladies and gentlemen, remember we assumed downwards to be negative. Okay, and again, that means upwards is positive. So a question that I'm posing to you is, will our final answer be a positive or a negative answer? Okay, so in the meantime, you can just make sure to comment. If you already know the answer, you can just guess. Otherwise, if you're confident with your answer, you can just comment and give a reason for that. Okay, so let's now continue, ladies and gentlemen. We just follow the same procedure that we followed there in terms of calculations. You move all of this to the other side. Remember, it's a positive and it changes as sign, it becomes negative. Then from there, you're going to divide by 6 so that it cancels and you remain with vi. Okay, so let's see, ladies and gentlemen. So remember, on the left side of the equal sign, it's a negative 92.4, close. Then you move everything to the other side. Okay, then it becomes 0.5 into 9.8, you close, then 6, and then squared. It's equals to, you get a negative number that you divide by 2. I'm not really sure if I squared, but I hope, let's see, ladies and gentlemen. Yeah, no, I noticed there's somewhere where I made a mistake. Let me just quickly try to check where I made a mistake, ladies and gentlemen. Let's see. Let's see. Oh yeah, no, I noticed exactly where I made a mistake, ladies and gentlemen. It's very, very much important that you make this kind of mistakes, especially when you're practicing, because when you get to an exam, you'll be aware of mistakes associated to this type of questions. Guys, remember, I substituted incorrectly on my calculator. Okay, so that negative sign is very, very much important, ladies and gentlemen. I changed that negative, that positive to a minus, but instead, when I was substituting into when I was punching on my calculator over there, I was supposed to substitute that negative there. Okay, so now I'm getting positive 84. Okay, so that means this is a positive 84, which is equals to 6v initial. So you just divide by 6 and you get the same answer as before, but in the opposite sign. Okay, so ladies and gentlemen, that means we have a positive answer for this question, which is 14 meters per second, then upwards. Okay, why upwards? Because we assumed downwards to be negative, and our final answer is positive answer. So that means the initial velocity is upwards. Okay, guys, remember, this question was allocated how many marks? I think it was 4 marks. Okay, so guys, in most cases they give you a mark for choosing the correct formula. They give you a mark for correct substitution, and then from there they give you a mark for your final answer, which is correct. Okay, and again, ladies and gentlemen, very, very much important. So they use the same criteria to mark this question. Okay, so if you answered it this way, they also give you a mark for writing the correct formula, and then again a mark for correct substitution, and your last mark comes from your final answer. Okay, which is correct in terms of the directions. Very, very much important, ladies and gentlemen. So now I think we can move to the next question. Okay, so I hope so far so good, ladies and gentlemen. I hope you fully understand exactly what I was doing, and I hope even if you're given a different question, you'll be able to tackle it with confidence. You won't get lost. You are now ready for this type of question. So ladies and gentlemen, can I just remove all of this so that we move to the next question? Remember, I'm going to make this lesson available online as soon as we are done. So you can just replay it over and over again until you fully understand, ladies and gentlemen. So now let's move to, should be a question 3.3. Okay, so guys, a very interesting question. So now they say draw a sketch graph of velocity versus time for the entire motion of the camera. Indicate the following on the graph: initial velocity, time at which it reaches the ground. And this question is allocated 4 marks. Ladies and gentlemen, it's very, very much important that you fully understand what the question wants you to calculate. Okay, so in this case, they just want you to draw a sketch. I'll just read the question for the last time, and then from there we'll try to draw that sketch. So they say draw a sketch graph of velocity versus time for the entire motion of the camera. Okay, indicate the following on the graph. Very, very much important, ladies and gentlemen. Indicate the following: initial velocity, time at which it reaches the ground. What does it mean when you're given this type of instructions, ladies and gentlemen? It means if you draw something and you don't indicate these two, you might lose some marks. Okay, very, very much important, ladies and gentlemen, that you fully abide by the instructions. Okay, so now let's draw a velocity versus time graph, ladies and gentlemen. A velocity versus time graph, and most importantly, for the entire motion of the camera. Okay, so we should obviously have the y-axis or the vertical axis representing the velocity in meters per second. Ladies and gentlemen, very, very much important that you write in meters per second. Okay, so again we've got the time, which is represented in seconds. Okay, so ladies and gentlemen, remember also when you draw this type of graphs, you still have to assume the directions. Okay, so that we are able to understand that, okay, remember, from that point going upwards is the positive side of the velocity. From this point to that side is the negative side of the velocity. Someone might be asking themselves a very good question. Ladies and gentlemen, someone might be wondering, why did I just do a straight line and then right in the middle draw the line for representing the time? So guys, remember, one could have said, why didn't you draw it this way and say v in meters per second and say time in seconds? Why did I extend it up to somewhere there? Ladies and gentlemen, it's because, remember, this is a vector versus a scalar graph. Okay, what do I mean by a vector versus a scalar graph? It's because the velocity is the scalar, is the vector quantity, which means it has the positive and the negative side of it. Okay, positive, which may represent that particular object either moving up or down, depending on what you assumed. Same for that negative sign. Okay, again, the reason why I didn't extend this line all the way up to that side is because I know the time is a scalar quantity and it only has the positive side of it. Okay, it doesn't mean as the object is moving upwards, its positive is positive 6, for example, and then when it comes down, its time will be negative 6 seconds. Okay, so in terms of time, we don't have positive and negative, it's just the positive number. So that is the reason why I drew this Cartesian plane in that way. Okay, I'm not sure if you understand, ladies and gentlemen, but I assume you do, because you fully understand what is meant by a vector and a scalar quantity. So that means, ladies and gentlemen, we're actually drawing a graph of velocity versus time, okay, which is a scalar versus, a vector versus a scalar, okay. So guys, we need to make those assumptions. Can we just start maybe by assuming positive to be upwards, ladies and gentlemen? So that means this graph will represent the scenario where that object goes up and the upward movement is positive, okay. So very, very much important, ladies and gentlemen, remember this object initially it moves upwards, right? At what speed or at what velocity? At a velocity of 14 meters per second, okay. So remember, if out of the balloon it will just go up and then reach its maximum height, and then from there it's going to come down to that same level and continue moving downwards until it hits the ground, okay. Very, very much important, ladies and gentlemen. So that means it's going to take it's actually going to take 6 seconds for its entire journey, okay. So that 6 seconds, ladies and gentlemen, it's when this object moves upwards with an initial velocity of 14 meters per second and reaches that maximum height, and again within that 6 seconds, that's when it comes down to that same level where it was dropped, and again within that 6 seconds, that's when it hits the ground, okay. So ladies and gentlemen, that means this object, as it goes up, it moves at its initial velocity as 14 meters per second, okay. As it comes down, when it gets to that level, its velocity will still be 14 meters per second, ladies and gentlemen. Then it starts to increase as it goes down, okay. But we're not really interested into what was its final velocity when it hits the ground, okay. So that means it's very, very much important for you to show that 14 meters per second, where on the negative side of that graph, okay. Very, very much important, ladies and gentlemen. And most importantly, remember, you were instructed to actually show the time, okay. So guys, we can just somewhere along that line, okay, somewhere along that line, show that time of 6 seconds, okay. So ladies and gentlemen, what does it mean, guys? What does it mean? It means this object, it actually went up, and as it goes up, what happens? Its velocity decreases until it's 0, and then from there, it comes down. Remember, it goes up, its velocity is positive, but it decreases until it's 0. There you go. From 14 meters per second, as it moves, its velocity decreases until it's 0. Okay, very, very much important, ladies and gentlemen. Then as soon as its velocity is 0, then it changes direction. It's now on the negative side, and its velocity starts to increase, ladies and gentlemen. Can you see? So guys, it's very, very much important that you indicate that it's not like at its velocity where it's negative 14, that's where the time is 6 seconds, okay. Remember, from that point it continues going down, okay. So this is that part where you show this object continuing in the downwards direction. Okay, so somewhere where its velocity is not calculated or it's unknown, that's when it hits, that's where it hits a time of 6 seconds. Okay, so very, very much important, ladies and gentlemen. So what I'm trying to say is you shouldn't have your graph which looks, let's say, which looks like that. As an example, ladies and gentlemen, as a solid line looks like that, because it seems as if it took 3 seconds for it to go up and another 3 seconds for it to come down to that same level. Okay, whereas they are saying it went up down to that same level and continues going down until it hits the ground within 6 seconds. Okay, so ladies and gentlemen, it's very much important that when you draw your graph, it corresponds to the interpretation. Okay, so guys, you'll be given a mark for showing, obviously, those that they wanted you to show, which is the initial velocity is shown, we give you a mark. Sorry, so the other thing is the time, we give you a mark. Okay, and most importantly, ladies and gentlemen, they also give you a mark for having extended that portion over there. It really shows an understanding, ladies and gentlemen. They give you a graph, and again, for just the type or the format in which your graph is represented, they also give you a mark for that. Okay, very, very much important, ladies and gentlemen. So it's easy if you assumed upwards as negative, let's say negative upwards, nothing complicated, ladies and gentlemen. You just draw this thing the very same way that you did. It's only let's say t there in seconds, let's say v there in meters per second. You still have your 14 there, you still have your negative 14 there. So you just start a line, from there. Then you can just go in that direction. Okay, then from there, somewhere there, this is where you can have your 6 seconds. Okay, so nothing different. Nothing different. It's just how you draw that graph. Let's just quickly try to interpret this graph, ladies and gentlemen. So it means as that object goes up, its velocity decreases. Can you see? Its velocity is decreasing until it's 0. Okay, which is that point there where it reaches its maximum height, and then from there it starts going down. Okay, so that's why the velocity is now positive. Okay, up until it reaches that same level, and then from there, which is that level there, of which the time we don't know how much it is. We can still calculate it, but the question didn't want us to calculate it. Okay, so now it continues going down, which is that point there where it hits the ground after 6 seconds. Okay, ladies and gentlemen, I hope you fully understand, and this question was allocated 4 marks, and that's how you score your full marks. Okay, so guys, let's now move to the next question. Ladies and gentlemen, this chapter is not that much complicated, and at the same time it's a bit confusing. You need to practice. That's why I do this type of lessons where I start you with the basics, and then from there show you how to approach this type of questions. I've done a full lesson, ladies and gentlemen. Please do make sure to check it out. Okay, you will have a better understanding. So now, ladies and gentlemen, they say if a jogger 10 meters away from point P, as shown in the diagram above, and running at a constant speed of 2 meters per second, sees the camera at the same instant it starts falling from the balloon, will he be able to catch the camera before it strikes the ground? This is a question. Use a calculation to show how you arrive at the answer. Okay, ladies and gentlemen, very, very much important that you understand what's going on over there. Okay, so let me just take this away and write important information there. Okay, so ladies and gentlemen, they are saying at that same time when that camera is being dropped. Okay, at that same instant, ladies and gentlemen, there's a runner who's running at a speed which is constant, and the speed is 2 meters per second. So remember, guys, by the time when he sees that camera being dropped, he was 10 meters away from that point P. Okay, so that means this is the point where that camera is going to hit the ground. Okay, so now they want you to calculate, and show by means of calculations if this runner will be able to catch that camera before it hits the ground. Okay, very, very much important, ladies and gentlemen. You can show this in 2 ways. Okay, so remember, guys, you can make use of the information by this guy to calculate how long it will take him to get to that point over there. We already know that as soon as this is being dropped, its full cycle to hit the ground is 6 seconds. Okay, it's 6 seconds. We already know. All right, so now we want to know, ladies and gentlemen, we want to know that this guy who is 10 meters away, will he get to that point P after or before 6 seconds? If we can answer this question by means of calculations, we'll be able to conclude, ladies and gentlemen. So remember, guys, everything is based on this information that we know, which is the time. Okay, very, very much important, ladies and gentlemen. You can either make use of the time or the distance covered. Okay, so ladies and gentlemen, let me just show you 2 ways in which you can answer this question. Okay, so guys, remember, what information do we know about this guy? We just know that he's 10 meters away, and again, we just know that he's traveling at a constant speed. Okay, so according to me, that means his V initial is equals to his V final, which is equals to 2 meters per second. Okay, so I won't stress that much. I'll just straight away go to the correct formula to use. Okay, so ladies and gentlemen, obviously this is the formula that you can use. Let me just say one of the formulas that you can use, ladies and gentlemen, over 2 change in time. This formula is given on your formula sheet. Okay, remember, guys, we're doing question 3.4, and it seems to be the last question of this question, and this question is allocated 5 marks. It's a lot of marks, and it's an easy one, ladies and gentlemen. So you deserve to be given all of these marks, not only because of the amount of work needed to perform the calculations, but based on how knowledgeable you are, based on your understanding of the scenario, based on your understanding of the question, ladies and gentlemen. So now, remember, guys, what are we actually trying to calculate here? We want to check how long it will take this runner to get to that point P when he's traveling or is jogging at a speed which is constant, and again, which is 2 meters per second. Okay, so that means at every meter, it takes him a speed of 2 meters per second. So I'm trying to say at every second he covers 2 meter, ladies and gentlemen. Let me just quickly try to check something, guys. At every 2 meters, right? At every 2 meters, it takes him what is it? It takes him 1 second. Okay, so for him to cover 10 meters, that means he must cover 2 meter, 2 meter, 2 meter, 2 meter. I'm just trying to check for him to cover 10 meters, how many seconds is going to need. Okay, just before I start to show that by means of calculations. So 1 second, 1 second, 1 second, 1 second. So that means it will be 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So it's more like he only need 5 seconds to cover that 10 meter. So he will get there before that camera hits the ground, because by the time when it gets there, it means that camera will be somewhere in the air. Okay, so guys, here I was just using my understanding or background or experience to just quickly check if it's going to get there without having to show by means of calculation. So this is what you'll be doing, ladies and gentlemen. Just substitute into the formula. Okay, so obviously his initial velocity is 2. You add final velocity, it's still 2. Okay, then you just divide by that 2 on the formula, and then from there, remember guys, what we're trying to calculate is the time. So we want to know how long it will take that jogger to get to that point P. Okay, so obviously 2 plus 2 is equals to 2. It's equals to 4, and then 4 divided by 2, it's equals to 2. Okay, so that means we actually have 10, which is equals to 2 change in time. Then we just divide by 2 on both sides so that it cancels. Then you have change in time, which is equals to 5 seconds. So ladies and gentlemen, that means I was right. It takes that jogger 5 seconds to that point P, and then by the time when it gets there, it means that camera will still be in the air. Okay, so he will be able to actually catch that camera. So when you respond, you just say yes. He will be able to catch the camera. Why? Because the time is less than 6 seconds. Did you hear that, ladies and gentlemen? I won't write it down because I know you'll always give the answer in the similar way. Ladies and gentlemen, you can answer it in different ways. Yes, he will catch the camera because he will get to point P before that object hits the ground, because it takes 6 seconds for it to hit the ground, and it will be there in 5 minutes time. In 5 seconds. Okay, so guys, they obviously give you a mark for choosing the correct formula, a mark for they've given you a mark there, but instead a mark for correct substitution, and again they give you a mark for correct answer, and lastly they give you a mark for the reason. Okay, so guys, the other way, I've just remembered that I wanted to show you 2 ways in which you can answer this question. Okay, so let's just quickly check something, ladies and gentlemen. Okay, so let's see. We still use the same formula, but want to know, or want to try and calculate how the distance that he's going to cover when he travels for that 6 seconds. Okay, let's try to check something, ladies and gentlemen. The initial velocity we know is 2, and then the final velocity, it will still be 2. You divide by 2, you use that 6 seconds. So you want to actually see if by that 6 seconds he will be still before that point P or after that point P. Okay, so ladies and gentlemen, this plus that is 4 divided by 2 is 2. 2 times 6, it's equals to 12. Then it's 12 meters. Okay, so ladies and gentlemen, it means after 6 seconds, as that object it's moving down, he would have traveled 10 meters plus extra 2 meters. Okay, so that means he's going to jog and get to this point. Okay, so by the time when he gets to this point, it means that's when this object was going to hit the ground if he chose not to catch it. But if he chose to catch it, he would have caught that a camera before it hits the ground. If we get a time which was less than 10 meters, that means he would be somewhere there when that object hits the ground, meaning he wouldn't have managed to catch it. Okay, so guys, they also use the same criteria to allocate marks for correct formula, for correct substitution, and again for a correct answer. And your last mark comes from you giving the correct reason. To say yes, he will be able to catch the camera because the distance covered, it's actually the distance covered within 6 seconds is greater than that 10 meters. Okay, so that's one other possible ways in which you can answer these questions if you decided to approach it this way. So ladies and gentlemen, I've actually started this lesson from the start up until the end without having a glass of water, and I can feel it that I'm a bit thirsty. So guys, thanks very much for joining, and I wish you all the best with your exams, and I assume you understood exactly what I was doing over there. So ladies and gentlemen, a day without learning something new, it's a day wasted. So please do make sure that you've learned something new by the end of this lesson, or you've learned something new in the end of each and every question. Guys, my name is Desmond, and I'm out.